This video is for Unit 2, Lesson 6, Exponential Functions. So our first problem says, evaluate the function for x is equal to -2. So by now, based on what you learned last semester, you should be familiar with the fact that when it says evaluate the function for something, that means you take that number and you plug it in to the function. So for this one, I'm going to take x is equal to -2 and plug that in for x. So I get y is equal to 6 times 2 to the -2nd power. So I know that a -2nd power means that this is going to be equal to 6 times 1 over 2 raised to the 2nd power, because if I have a negative exponent, I can make it positive by making it 1 over the base to the positive exponent. So when I simplify this, this is equal to 6 times 1 over 4, and then 6 times 1 over 4, I can make this 6 over 1, multiply sort of across, but I didn't draw it so that it's easy to see that it's across, but multiply the 6 times the 1 and the 1 times the 4, and I get 6 over 4, which I can then simplify by factoring a 2 out of the 6 and the 4, and finally get 3 over 2. So when I evaluate the function for x is equal to -2, I get y is equal to 3 over 2. So my whole answer, another way to write it would be as a coordinate pair. So it would be x is -2, y is 3 over 2. Would be another way to write that answer. All right, so that is how you evaluate a function. So for the most part, we really don't do a whole lot of that in this lesson, but it is important to know that that is how you solve if you have an exponent. So what is an exponential function? So this, you may have guessed, is an example of an exponential function. All exponential functions are written like this. Y is equal to a times b raised to the power of x, and a and b are going to be numbers. So your x and your y are your variables, just like in y is equal to mx plus b. You keep your x and your y as variables, and your a and your m and b are numbers in the equation. So an example of this would be the first problem that we had, and then also like y is equal to 4 times 2 raised to the power of x. That would be another one. And you just have to make sure that a is not equal to 0, because if you had a equal to 0, then you would end up with y is equal to 0 times, say 5 to the power of x. No matter what, this is just always going to be equal to 0. So it's just kind of not anything. It's just y is going to be 0 all the time, because anything times 0 is equal to 0. B has to be greater than 0, so you can't have a negative base. And you can try that out yourself. I'm not going to go into why, but it just doesn't work. And b can't be 1, because if you have, for example, y is equal to 2 times 1 raised to the power of x, well, 1 times itself is always going to be 1. So you could have like 1 raised to the power of 1,000,000, and it's still just going to be 1. So again, it's just not giving you a function there. So these are examples of what exponential functions look like. So there's 4 different examples here, and we're going to get into a little bit more of like how you get each of these different shapes. But here's some examples. It's always going to be kind of like a curve. Or not kind of like a curve. It is a curve, but there's different kinds of curves that it could look like. So next I want to talk about if a table represents an exponential function. So previously we learned that linear functions have repeated addition in the patterns of the x's and the y's, but for exponential functions you're looking for repeated multiplication, because if you think about y is equal to a times b raised to the power of x, if we have x is 1, we're basically just looking at y is equal to a times b. If we have, so I'll write this off, x is 1. If we have x is 2, then I get y is equal to a times b squared, or a times b. So essentially, if you're adding 1 to every x value, you're just going to be multiplying one more time times that b value. So we're looking for repeated multiplication. So if I look at this table, to go from one x value to the next, I'm adding 1. So that's fine. And then to go from 1 to negative 2, I would multiply 1 by negative 2. But then from then on, in order to get from negative 2 to negative 4, I would multiply it by positive 2. And then again by positive 2 and positive 2. So this would not be an exponential function because that first value, I would have to multiply it by negative 2 to get the next value, and then the rest I'm all multiplying by positive 2. So because I'm not multiplying by the same number every time, it is not an exponential function. And the next example, so it looks like I'm still adding 1 to each x value to get the next x value. And then when I look at my y values, to get from 2 to 4, I'm multiplying it by 2. And then from 4 to 6, I'm multiplying it by 2. Or no, I'm not multiplying it by 2. I'm adding 2. So because this is not 8, and I'm adding 2 instead of multiplying 2, then this is not going to be an exponential function. So just for fun, let's change the first one so that it is an exponential function. So if I make this negative 1 instead of positive 1, then it would be an exponential function because I would be multiplying negative 1 by positive 2 to get negative 2. And then I would be repeating that pattern for everything else. So just by doing that, I am changing this so that it is an exponential function. But the second one is not going to be an exponential function because I'm adding 2 each time. So it would be a linear function, but not an exponential function. So let's take a look at some of the different things that happen when we are looking at exponential functions. So I've already typed this in. The way that you can type this in is just type in y is equal to a, and then the multiplication sign is shift and 8. It looks like a little asterisk on your keyboard, and then you can put in that multiplication sign, and then you need b raised to the power of x. So there's two different ways that you can do that. You can either type b and then shift 6 and then x, or if you prefer, you can use the keyboard and click on this a to the b. Oops, I need my b. And then click the a to the b and then type in an x there. All right. So then I want to look at what is happening with my a's and my b's. Like, what changes this? So if I just start out with a is equal to 1 and b is equal to 1, then it's just this flat line. And remember, my definition earlier said a is not equal to 0, so a can be 1, but b has to be not equal to 1 because that's what makes it that flat line. So b has to be something that's not 1. So let's move it to 3. So we moved it to 3, and now we've got this kind of curve. So if a is 1 and b is 3, it's like increasing. It's got this growth. So then one thing, let's see, what order did I write these questions in? What do I want to talk about first? Okay, what happens when b is equal to 1? So when b was equal to 1, it was a flat line because we already talked about earlier. If b is 1, it's just always going to be 1 to the power of whatever, which is just always going to be 1. So when we increase b, that gave me this growth curve. What happens when b is between 0 and 1? So let's change that b value to be between 0 and 1. And notice it's no longer curving upward. And we always read graphs from left to right, like we're reading a line in a book. So when we read it from left to right, this is going to be decreasing and getting closer and closer to that x-axis. And then If I make it less than 0, or if I make it 0 or less than that, it just disappears because it just is not, it's not a thing. So this is still above the x-axis, but now it's decreasing from left to right. Okay, so we're going to set b is equal to 2. And then what happens when I change a to be 4? All right, so this is when a is 1. If I change a to be 4, notice that that changes my y-intercept. So that a is going to be your starting value in a way. It's going to be your sorry, not x-intercept, y-intercept. It's always going to be your y-intercept. Because, let's think about that, on the y-axis, x is going to be equal to 0. So if your a is 4, then you get y is equal to 4 times, in this case 2, raised to the power of 0, right? Because if you plug in 0 for x, that's where you're going to get your y-intercept. And anything raised to the power of 0 is going to be 1, so I'm just going to be multiplying that a times 1. And that's going to be true like for any exponential function. If you have an x of 0, then you're just multiplying that a value times 1. So your y-intercept is always going to be that a value. So that's another thing to keep in mind. Let's see. What happens when a is equal to 0? Let's see that. A is equal to 0. Yeah, so now it's another flat line. And I mentioned this before because if a is 0, y is just always going to be 0 because you're multiplying 0 by everything. So that makes sense. And then what happens if a is negative? So when a is negative, notice that it sort of flipped the graph so that it's below the x-axis. So when a is negative and b is greater than 1, then you get this decreasing graph. And then when I make b in between 0 and 1, then it gives you this graph. So it is increasing, but then it gets closer and closer to the x-axis. So it's still increasing from left to right, but it's not like, it's not what we would call, or it's not like growing off into like way positive y values. So anyway, that is how you get the 4 different kinds of graphs. So you have b between 0 and 1, and then you can have positive and negative a values. And if the a value is positive or negative, that will tell you whether it's flipped above or below the x-axis. And then if the b is between 0 and 1, then it's going to be exponential decay. And if it is greater than 1, then it's exponential growth, which we will get more into in the next lesson. So let's see. Okay. So the last question, not next question, very last question, says, Lex Luthor spends most of his time being a villain, but he is also a successful businessman. He has decided to invest some of his money in a savings account while he is in jail. Lex invests $5,000 and his investment will double every decade. And then we have the function, and where x is the number of decades that have passed, models the amount of money Lex will have in the savings account. If Lex is in jail for 30 years, how much money will he have when he gets out? So it says x is the number of decades that have passed. And that's the important part, because if he's in jail for 30 years, that means 3 decades. So I just take 3 decades and plug that in for x, and I get f of 3 is equal to 5,000 times 2 raised to the power of 3. Now at this point, it's not really worth me multiplying 2 by itself 3 times and then trying to multiply that by 5,000 on my own. So actually I will just use Desmos. So I want 5,000 times 2 to the third, and I get $40,000. So that's how much money he'll have.